Now we introduce a technique for computing the answer to a linear system that works only if the linear system has a very special form. It's called a triangular system. Here's an example. To solve this, let's rewrite x as the vector of x1, x2, x3, and x4. Then the system looks like this. How would we solve this system? Well, look at the last fourth equation. From this, we can immediately derive the value of x4. Having derived the value of x4, we can plug it in to the third equation and solve for x3. Now we've got x3 and x4. We can plug those in to the second equation and solve for x2. And finally, plug x2 and x3 and x4 into the first equation and solve for x1. So here's how that works. We solve this fourth equation to get, the fourth equation states that 2x4 equals 6. We can solve that to get x4. We plug that in to the third equation, and we find out that 1x3 equals minus 19, so x3 is minus 19. We plug x3 and x4 into the second equation. We find out that 3x2 equals 54, so x2 equals 54 over 3, which is 18. And finally, we plug x2, x3, and x4 into the first equation. We find out that 1x1 equals minus 67. So we've solved for all the variables. Now, how would we implement this in Python? Well, I'm going to suggest a hack. You initialize vector x to the 0 vector. And now the procedure will populate the vector x entry by entry. At the point where you have to solve for some entry xi, the subsequent entries in the vector will have already been populated. So we can use the dot product to help simplify the calculation for that entry. So, for example, suppose we're solving for x2 using this equation. Well, at that point, we already know x3 and x4, and the vector has those entries populated. So that we can take the dot product and compute x2 in this way.